Welcome to Brain Vision.
Chapter 3, Problem 26. Define atomic radius. For main group elements, describe the observed trend in atomic radius as we move across the periodic table or move down a column in the periodic table. So with nonmetals, you can define atomic radius as half the distance between bonded atoms. Let's say we have two atoms that are bonded, and they're both nonmetal. Let's say it's two bromines or two chlorine atoms bonded together. And the dot represents their nucleus. If you take the distance between the nuclei, and unlike the electron cloud, which you can't define, you can identify exactly where the nuclei is. You take this distance and divide it by half, you get the atomic radius of each atom. For metals, it's similar, but metals, a solid metal is in a crystal. And so what you can do is something very similar, but take half the distance between two atoms in the crystal. If you take half of this distance here, you would get the distance of one atom, giving you that atomic radii. As you move across the table, the atomic radius for each element will change. So if we think about the structure of hydrogen, hydrogen has one proton in its nucleus. So let's draw, this is hydrogen. It has one proton. In its period, the next atom that we have is helium. Helium has two protons. In a neutral atom above, you will have one electron here on the first energy level. And then the neutral atom of helium, you have two electrons on the first energy level. Now, this is +1, this is -1. These charges attract each other. However, when you have helium, you have two positives and two negatives, meaning this is a stronger positive, this is a stronger negative, there is a stronger attraction. When this happens, the atom of helium is smaller because the proton and the electron cloud are pulling closer towards each other, resulting in a smaller size atom. Whereas hydrogen, one proton and one electron, they're still attracting each other, but each charge is not as strong, so it's a bit bigger than helium. So as you move across the periodic table, the atomic radius goes down. Now, if we think about that in terms of moving down, let's say we have hydrogen, one proton, one electron, and then let's do an atom of lithium. And lithium has 3 protons. And a neutral atom will have 3 electrons. Now, the size in which I'm drawing these atoms is irrelevant. We're just going to focus on the explanation of the atomic radius. So with lithium, you have 2 electrons on the first energy level. The second energy level has 1 electron, giving us a total of 3. So what happens here is these protons feel these electrons feel this positive nucleus and it's attracting it, but you also have an electron on the outer level that does feel the positive nucleus, but not as much because it's further away. So this electron does not feel this positive charge as much because there's electrons in the way that are semi-blocking it. That's called shielding. And so when this electron is shielded by this, it's repelled and it's pushed a bit further out. Therefore, this electron isn't pushed out by any charges, and all it feels is the positive charge here, and these two are attracted. So when you go down a periodic table, you're adding an additional energy level, and that causes the atomic radius to increase. When you go down a column in the periodic table, your atomic radius goes up.